In this particular video, we'll talk about UART protocol. UART stands for Universal Asynchronous Receiver Transmitter. The name itself gives us an idea that it is an asynchronous protocol, which means there has to be no clock present. And as you can see in the figure, there is no clock present between the two UART devices. So UART stands for Universal Asynchronous Receiver Transmitter. This protocol is used for device-to-device communication protocols. UART can work with many different types of serial protocols that involve transmitting and receiving of serial data. UART is a hardware communication protocol that uses asynchronous serial communication. Asynchronous, as all of us know, means that there is no clock signal in order to synchronize the output bits from the transmitting device going on to the receiving device. In UART, the mode of transmission is in the form of a packet. So, what is happening? Since there is no synchronizing clock over here, the devices, that is UART device 1, UART device 2, have to independently work on synchronizing of the data. UART asynchronous means that since there is no clock signal, so therefore synchronizing comes down to the individual capability, which I already mentioned right now. The main purpose of a transmitter and the receiver line for each device is to transmit and receive data, serial data intended for serial communication. This is also a serial communication protocol. The transmitting UART is connected to a controlling data bus that sends data in a parallel form. From this, the data will now be transmitted on the transmission line via serially, bit by bit, to the receiving UART. This, in turn, will convert the serial data into parallel for the receiving device. For UART and most serial communications, the baud rate needs to be the same on both the sides, at the receiver and the transmitter. The baud rate plays the synchronizing part over here, since there is no clock. Instead of the clock signal, the transmitter generates a bit stream based on the clock signal, while based on its own clock signal, while the receiver is using its own other entirely internal clock signal in order to sample the incoming data. Therefore, since both of them are operating on their own separate clock signals, that means that they have to synchronize with the help of baud rates only. In case of synchronous data transmission, there is a common clock. The point of synchronization is managed by having the same baud rate on both sides. The allowable difference on baud rate is up to 10% before the timing of the bit gets too far. Okay, so asynchronous doesn't mean that the device itself cannot have the clock. That is not the idea we want to propagate. The idea is that there will be never be a common clock between them in order to synchronize. Synchronization is what makes them different, and hence their name is asynchronous and synchronous, not as clocked and unclocked. So that's a point of difference right over there. Asynchronous and synchronous differ in their synchronization, and the main aspect going over there is clock, agreed, but that refers to the common clock, presence in the absence of the common clock. The devices can by themselves have individual clocks. That is not an issue. And again, in UART, the data transmission happens in forms of packets. A packet of data is sent which has a start bit, the data frame, parity, and stop bits. Start bit tells that the data transmission has to be started. Data frame contains the data that has to be transmitted. Parity contains is basically checks the correctness of the data that is being transmitted, whether the correct data is reaching the other receiver or no, and the stop bits end the communication. This is how the communication propagation is happening with the help of a UART protocol.